Hello everyone, welcome back to the channel. Today we are looking at one of the most interesting fighter jet comparisons in modern air power, the Israel upgraded F-16 versus the Russian MiG-35. These two aircraft represent the peak of five-generation technology coming from two very different military philosophies. One is built on decades of Israeli combat experience and American engineering, while the other reflects Russia's push to modernize its legacy platforms and compete globally. In this video, we will break down their upgrades, avionics, sensors, weapons, performance, and battlefield roles. By the end, you will understand how they stack up against each other and which one holds the advantage in real-world situations. The Israeli upgraded F-16 is not just an old platform with new paint. Israel has heavily modified and enhanced its F-16s over many years. These upgrades include advanced mission computers, high-resolution displays, modern electronic warfare systems, and new radar capabilities. Israel customizes its aircraft specifically for the threats it expects to face. That includes dense air defense networks, fast-evolving missile threats, and unpredictable regional conflicts. The upgraded F-16 is designed to survive, adapt, and strike in some of the most contested areas in the world. This makes it one of the deadliest legacy fighters still flying today. On the Russian side, the MiG-35 is marketed as the latest evolution of the MiG-29 family. While Russia promotes it as a 4++ generation fighter, the reality is more complex. The aircraft does include improved avionics, new radar options, better fuel efficiency, and a higher payload capacity compared to older MiG-29 variants. But Russia still struggles with production scale, export interest, and financial limitations. Nevertheless, on paper, the MiG-35 brings many modern features such as ESA radar, helmet, mounted sights, advanced missiles, and enhanced maneuverability. It is meant to be a cost-effective multi-role fighter that competes with Western 5th-gen jets. When we compare the radar systems, Israel's upgraded F-16 gains a major advantage. Many Israeli F-16 variants have been updated with locally integrated avionics and advanced data processing systems that outperform typical export F-16 blocks. Israel's electronic warfare suites are among the best in the world, shaped by constant real-world combat. These systems detect, jam, and deceive enemy radars with extreme precision. Russia claims the MiG-35 can use an ESA radar called the JAKM, but there is limited verified data about its real performance. Even Russian sources admit production delays and reliability issues. In contrast, Israel's refurbished radars and targeting systems have been tested repeatedly. Sensor fusion is another area where Israel pulls ahead. Modern Israeli F-16 upgrades integrate radar information with targeting pods, satellite data, drone feeds, and battlefield networks. Pilots get a clear and real-time picture of what's happening around them. This gives them superior situational awareness. The MiG-35's fusion system is improved compared to older Russian jets, but Russia has historically lagged behind NATO and Israel in network integration. In a modern battlefield, whoever sees first and reacts first survives. The Israeli jet has the stronger advantage here. When it comes to maneuverability, the MiG-35 is designed to shine. Russian engineers built it to perform high-G maneuvers, quick turns, and aggressive dogfighting tactics. The aircraft has a strong thrust-to-weight ratio and aerodynamic design suitable for close-range engagements. The upgraded F-16, although extremely agile, is slightly less maneuverable in raw aerodynamic performance. But air combat is no longer centered around turning fights. Today, stand-off weapons, stealth tactics, sensor networks, and long-range missiles decide the battle long before jets get close enough to dogfight. This means that maneuverability alone cannot compensate for weaker sensors or situational awareness. Another critical factor is weapons integration. Israel has one of the most advanced air-to-air and air-to-ground weapons arsenals in the world. Their upgraded F-16s can fire AIM-120 AMRAAMs, Python missiles, Spice-guided bombs, Delilah cruise missiles, and many other Israeli-made precision weapons. This gives Israeli pilots flexibility and options in any mission profile. The MiG-35 can carry R-77, R-73, guided bombs, and anti-ship missiles. These weapons are solid, but Russia's missile technology often struggles with reliability, seeker quality, and electronic counter-measure resistance. Israeli munitions are continuously upgraded and battlefield, tested across multiple combat zones. When it comes to survivability, the Israeli F-16 stands out again. Israeli engineers built advanced self-protection systems that detect incoming threats, jam enemy radars, spoof infrared seekers, and automatically deploy countermeasures. These systems are so effective that some analysts consider Israeli fighters among the hardest to shoot down in the world. The MiG-35 does include modern warning systems, but there is no confirmed evidence that they reach Israeli standards of reliability or sophistication. Real combat history strongly favors Israel's approach. The cockpit and pilot experience also differ. In upgraded Israeli F-16s, pilots get advanced digital displays, intuitive controls, and seamless integration with helmets that provide targeting and tracking information directly in their line of sight. Israeli pilots are trained extensively in real mission scenarios, simulations, and fast-changing combat environments. Russia's MiG-35 cockpit is improved compared to earlier models, but it still lacks the same level of software refinement and ergonomic design. Russian pilots also do not get the same volume of training hours that Israeli or Western pilots typically receive. Operational range is another important element. The MiG-35 has more internal fuel capacity and can carry drop tanks for extended missions, giving it a respectable range. The Israeli F-16, with upgraded fuel systems and conformal fuel tanks on certain variants, can also fly long missions without support, but Israel has serious expertise in aerial refueling and long-range strike planning. The combination of long-range weapons, networking, and support infrastructure gives the Israeli aircraft a more strategic reach despite its smaller frame. Maintenance and reliability offer one of the biggest contrasts. Israel maintains a strict and highly advanced maintenance ecosystem. Their upgraded F-16s undergo regular modernization and health monitoring. Spare parts, diagnostics, and repair capabilities are world-class. Russia, however, struggles with maintenance logistics, spare parts shortages, and budget constraints. The MiG-35 may look impressive in demonstrations, but its long-term support and operational readiness remain questionable. Aircraft performance is not just about flying ability, it is also about how often the jet can actually leave the runway. Combat record is another major separation. Israeli F-16s have decades of real-world experience, taking part in major conflicts and precision operations. These jets have destroyed air defenses, engaged enemy aircraft, struck high-value targets, and carried out complex missions. The MiG-35, on the other hand, has almost no confirmed real combat use. It remains more of a promotional platform than a battlefield-proven fighter. In any real war scenario, combat history matters because it reveals how well a system performs under stress. Export success is also revealing. The MiG-35 has struggled to secure major international buyers. Many nations that once operated MiG-29s decided to move toward Western aircraft instead. Concerns about logistics, upgrades, and long-term support discourage new customers. In contrast, upgraded F-16s remain in high demand. Many air forces prefer to modernize their existing fleets rather than abandon them. Israel's upgrade packages make the F-16 competitive even against newer fighters, keeping it relevant and trusted worldwide. Now let's talk about mission roles. The Israeli F-16 upgrade is designed for multi-role dominance. It can switch from air superiority to deep strike missions within minutes. It handles reconnaissance, air defense suppression, precision bombing, and defensive patrols with equal effectiveness. The MiG-35 is also marketed as a multi-role fighter, but Russian doctrine often prioritizes air-to-air engagements and limited strike missions. This makes the Israeli aircraft more flexible, adaptable, and mission-ready for diverse tasks. When we compare cost-effectiveness, Israel scores again, upgrading an existing F-16 into a near 4.5 Gen fighter is significantly cheaper than developing or purchasing new aircraft. These upgrades extend the jet's life by decades while giving it modern capabilities. The MiG-35 is marketed as a low-cost option, but operational costs, maintenance challenges, and limited export interest make it less competitive overall. Buyers prefer aircraft with strong global support networks and proven performance, something Russia cannot always guarantee. Electronic warfare is one of Israel's strongest areas. Its self-protection suites are so advanced that many Western air forces adopt similar technologies. These systems give the upgraded F-16 the ability to blind, confuse, or mislead enemy radars and missiles. Russia's electronic warfare is powerful on the ground, but its airborne EW systems have not consistently proven superiority. The MiG-35 has electronic countermeasures, but again there is limited proof of their effectiveness in real conflicts. Another important advantage of the Israeli jet is battle network integration. Israeli fighters operate within one of the best command and control networks in the world. Data from drones, satellites, air defense systems, and ground forces flow directly to pilots. This turns every pilot into a mobile battlefield commander with instant awareness. Russia's network systems are improving, but still lag in speed, encryption quality, and reliability. In modern warfare, the network is as important as the jet itself. Looking at manufacturing quality, Israel benefits from American standards and its own aerospace technology. The upgraded F-16 maintains high structural integrity and excellent durability. The MiG-35, while improved, still faces concerns about build consistency. Russian aircraft production has suffered from economic pressure and material shortages, which affect long-term reliability. The strategic environment also shapes their effectiveness. Israel's F-16s are designed to face multiple threats at once, including advanced air defenses, hostile fighters, and long-range missiles. Every upgrade Israel introduces is tested through real combat scenarios or realistic simulations. The MiG-35 was designed more for export and demonstration purposes, with fewer opportunities to prove itself under pressure. In the end, both aircraft represent strong 4.5 Gen capabilities, but the Israeli upgraded F-16 stands out for its real-world success, modern avionics, advanced weapons, powerful EW systems, and unrivaled combat experience. The MiG-35 is an upgraded design with potential, but it remains limited by development issues, lack of combat history, and weak export performance. In direct comparison, the Israeli F-16 upgrade is more mature, more reliable, and more effective on the modern battlefield. The final question is which aircraft would likely dominate in real combat based on sensors, weapons, network integration, pilot training, and electronic warfare advantages. The Israeli upgraded F-16 would most likely achieve the first shot and maintain control of the engagement. The MiG-35 could perform well in close combat, but modern air battles rarely reach that point. The Israeli jet's superior situational awareness and long-range strike capability give it decisive superiority. Thank you for watching. If you enjoyed this comparison and want more high-quality breakdowns of advanced military technology, make sure to subscribe, like, and comment below. Your support helps us bring you the most accurate and detailed defense analysis possible. Stay tuned for more videos, and we will see you in the next one.